Let's discuss the different compute engines that you have in Azure. In this session, we are going to talk about specifically about Azure as the ecosystem. And if you're implementing something like a Lakehouse architecture within Azure, what are the different compute engine options? Um, we will only talk about Azure. Will not discuss about Microsoft Fabric at this stage because Fabric is again a different platform, though it is based on Azure. Let's stick to Azure and what all services that you have. Within Azure, you might have already used things like ADF. There is HD Insights, okay, and finally there is Synapse. So we are going to focus mainly on the Synapse side of the things. ADF is mainly used for ingestion. Yes, you can use it for data transformations and all. HD Insight gives you the Hadoop side of the things if you want to implement some of the Hadoop frameworks. But Synapse is something which is more popular in terms of doing big data processing as well as data warehousing kind of a stuff. Now in Synapse, again, you get three options. Okay, the first is you get the option for running Spark through the Synapse Spark pools. You can create Spark notebooks. So eventually these are nothing, these notebooks are like your normal notebooks. You can write your PySpark code and attach the Spark pools to this. So you get this as a one of the option. The second is the Synapse, it is called as the serverless SQL pools. So this is where you can write your SQL queries. And third is the dedicated SQL, right? Dedicated pools. It's called as, I believe, dedicated pools. So what is dedicated pools? It is similar to the older traditional data warehouses where you have to load the data into the warehouse. Now, if you have worked on things like Redshift or BigQuery or Snowflake for that matter, right? um, how these warehouses work is like you have data in your data lake. Let's say this is a data lake and there is a separate warehouse. So data lake here is ADLS gen 2 and the warehouse is the Synapse dedicated pool. So you will have to first load the data and then work on it. Okay, so you get all the performance related you get better performance if you are using dedicated SQL pools and all. Again, if you're working on just a Lakehouse architecture, let's stick to these two frameworks. Okay, what is Lakehouse architecture is just a quick recap. We have discussed it multiple times, but Lakehouse is something where you don't really have to move the data into a warehouse. So it is basically a data lake. Okay, you use things like S3, ADLS, and if you're going to Google, it is GCS. Okay, plus you have the open table formats on top of it. Okay, open table format. So maybe we can have a separate video for this to explaining these in details. But for time being, just try to understand Lakehouse is nothing but a data lake with where data is stored within the cloud object storage and using open table formats like Delta Lake, Hoodie, or Iceberg. In such cases, you cannot or you don't want to use a dedicated pools because you don't want to move the data anywhere else. You want to keep all your data into ADLS. That is a single storage tier. So in Lakehouse, you just have a single storage tier. That's the data lake or the cloud object storage, and you can bring in multiple compute engines. So you get the freedom of having a separate compute, separate storage. So storage is ADLS Gen 2, and you can have any other compute that you want. So in our case, it can be the Synapse Spark notebooks or it can be the serverless SQL pools. Why we need two different engines? Because data engineers generally prefer this Spark notebooks. Data analyst, business analyst, whoever wants to write the SQL queries and all, they can use serverless SQL pools. So how this work is like here you will get a notebook kind of an environment. Okay, like your Jupyter notebooks or any other notebooks that you have seen, and you can write your code where you can create data frame and all those things. Okay, eventually you can attach some Spark pools to this. So again, you have to create a Spark cluster which is of um, multiple data nodes or the worker node, sorry. So there would be a master node and there would be multiple um, data nodes, right? So there is a driver and then executors, right? If you go back to the Spark concepts. So you can create this cluster and you can attach it to this notebook when you want to run it. Now there are different versions of Spark that you get. We'll talk about it in a bit. Okay, I'll show you maybe on the Azure documentation itself what options we have. So this is one of the options, and you can create your notebooks and run it. If you want to orchestrate these notebooks, you can very well do that through the ADF also. So ADF pipelines, you can trigger a Spark notebook. So that's generally how a notebook is triggered. Now, for others who don't want to use Spark, so here also, right, you can still write your Spark SQL and all. Even you can write those queries here. Since this is a notebook, you can write directly using the magic command. If you know what these are, those who have worked on Databricks also, they might be aware. So you can write percentage SQL and write your queries, and you would be able to run it. Now, serverless SQL pools, it's a different engine altogether. It's not a Spark engine, okay? Not Spark engine. This engine is based on something called as a Polaris engine. It is a very it's a different. It's not even Trino or Presto. It's a completely different engine. There's a good white paper on this. You can check it out. So that engine is used to run this service, that is Synapse Serverless SQL. Here you can write your queries on directly on the Delta Lake. So if uh, Delta Lake, because I'm talking mainly from the Lakehouse perspective, that is the modern way of doing the things. If you're using just Spark, I think it should work with that. But if you have a Delta Lake, you can directly query that. Okay, so you can query your Delta tables. Now there are certain limitations with this. Again, maybe I'll show you the link for that. There are certain limitations. A lot of things are not possible maybe at this stage. Maybe in future Polaris may start supporting it. You cannot really do time travel here. So time travel is, time travel and updates. These are the two basic things which you get from the open table formats like Delta Lake. That's why people generally use the open table formats. Unfortunately, in these serverless SQL pools, it's not currently supported. But if you want to do such things, you can go to the notebooks and write a SQL and get that done. So that's still possible. Um, in either case, right, Spark notebooks or serverless SQL pools, the good thing is you don't have to keep them running. You can stop them, you can pause them, right? So you will be charged. You'll have to pay based on your consumption only. So these are pay as you go services. In fact, serverless SQL pools, the costing is different. I think it is based on the data scanned, how much data you scan. It is based on that. So you can do some, and there is a minimum limit, and also you can think about doing some optimization there as well. But yeah, these two are the most important services, at least in today's world. If you are working on the Azure Synapse kind of a implementation for working on a Lakehouse kind of a project. If you are using Fabric, then things change a bit. At the end, Fabric also has Synapse as the core service. It is a wrapper on this, but with a lot of other optimizations as well. Um, uh, yeah, I think that is what I wanted to cover. The couple of other links which I wanted to show you are, let me see if I can show them. Yeah, so these are the serverless SQL limitations that I was talking about. Okay, see, serverless SQL pools, you cannot really run the time travel queries. So if you want to go and see what is time travel, the previous versions of data, you won't be able to see that. That's one of the issue there. The other is you cannot really do an update, as I mentioned earlier. Okay, and there are several other limitations which you can have a look at it. So this is related to the Synapse serverless SQL pools. The other important factor, so these are some of the key considerations, right? I'm not going through everything. It's more from a data architecture perspective. Like as an architect, what are the key considerations? What you should look at? This is the other one where you should look at the Synapse Spark runtimes that it offers. So the latest one that Synapse offers is the Spark 3.4, which was GA'd as on 8th of April 2024. So it's still not the latest. I think 3.5 is not yet here. It might come, but I'm not sure. They have not mentioned it. Always look for this. What is the Spark version? Okay, 3.4.1, and what is the Delta version? So if you say Delta 2.4.0, so it's pretty old. I think Delta 4.0 was recently, just couple of days back, it was announced. So if you see, it's pretty old. So I think with 3 point Spark 3.5, you get the Delta 3. So at least we should have that, but we'll have to wait till it comes here. Now, those who want to really try it out, the higher version, maybe you can try configuring that. I'm not sure how that works, but you can try it doing on HD Insight also. You can install your own Spark and also try to do that. But then with Synapse, right, you get it out of box, so it is much easier to use it. So go with what you have until unless you have a use case where you want some very specific version features which are available in 3.0 and all. Maybe the deletion vectors and all. I don't remember which are the features which are not there in between 2.4 and 3, but you can have a look at it. If at all you need that, then you can see what are the different workarounds. Can you configure that within the Spark notebooks here? But always try to use what is there out of box because it is much easier to use. So yeah, these two documents, I think these two links are important. You can have a look at it and then you can take a final call. How do you want to use it? So as an architect, look at all these things when you are trying to, or when you are choosing a compute engine for your data platform, implementing particular use cases. There are multiple options. Please go through all of them, and if you want to provision all, even that is fine, because that's the beauty of having your compute and storage as separate. It is just that the versions you have to check. What I mean by that, the version of Delta, right? If you try to create a Delta Lake from EDF, not sure what version it creates as against the Synapse created files. It might be different. I'm not sure whether this is documented, but should have a look at it. Always the versions are compatible. Generally, these are backward compatible are there, so it should not be a problem if you're trying to use what is created from EDF into Synapse. But if it's the other way around, maybe you'll have to test it out and see how things work. That's it for today's session. Thank you, and see you again soon.